didn't move too much. Mr. Richmond. Why is that? Alright, because first answer, you should have gotten 6.881, true?
Yes.
Yeah. So 6.882, that's okay, I'm just showing you the full answers, right? We're just checking the handbook. Starting on page 10 in the middle. What was it asking you to do to input square root of 3 squared plus 5.6 squared? Were you supposed to type the whole thing over again, or was it trying to help you out with how to do it shorter or quicker? How? Okay, if you have an old calculator, you can. I oriented my screen. Okay, never mind. I'm using my mouse. Okay, so it hasn't been working for like 6 months, and it just started working, so maybe it's still something. Okay, you can do second enter, and if you use second enter, it does repeat whatever you did right above. And for older calculators, aka the yellow button, that's what you need to do. But for newer calculators, oh, there's such a better way. What's that better way? Go up and say, I want you, please. Hey. And then you can go ahead and go on over and say, all I need to do is change the 3, which my calculator has a lag, so it takes forever. Yours will probably go faster. Change it to a 3 and say, dun, 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 6.353, right? 6.353. Anyway, I'm trying to make sure you guys know how the shortcuts work. And then, what are we changing on number 14? 3 to the power of? Okay. So we could do 3 to the power of. If you wanted to, you could go ahead and say, hey, is this going to work if I go back and if I, oops, not that one, the other one. Click it. Go team. Could you also have done second enter? Yes. Both of them would have worked. People with the yellow button, second enter, once again, is your only option. 1920.798. Sound good? What craziness is going on here? This is a great button, by the way. It is a stupendous button. Which button are they introducing to you in this section? Stow. You're going to stow it. Big store, right? You're going to stow it away? So where's the stow button? Now, if you're stowing something, well, okay, this button can also be used in some of the programming. If you guys actually did read and follow in detail the list section, they had that one part where they came to the home screen, they did like L1 with an arrow, and then they showed the list, and then they entered it. That arrow is the stow. Stow is seen as an arrow when you just try hitting it right now. That's right, this doesn't work. Okay. It works when I write. Stow. Stow is the arrow. But besides programming, stow always means take what is there and put it in basically a variable. So as you guys were reading down here, you had just done 3 to the power of blah, 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 blah. We wanted to compute this, and it would be kind of messy to use what we did up here because it just starts getting really complicated when you put that in there. So they say stow this answer, stow it, little arrow. How do I get an A? Good, alpha A. Alpha math, technically. These little green letters are the alpha characters. If you hit enter now, whenever you hit A, it's going to mean 1920.798, which is pretty cool. Now, don't use this for cheating purposes, but it can be pretty cool like on a homework assignment, right? If you need like Avogadro's number or something, you just store it as a variable and just keep on putting it in a variable. Unless you're just like typing it in over and over and over again. Okay, moving on. So let's check that answer really quickly. 2 to the power of 4.7. Did you guys figure out that you need to get outside of the power before you keep typing?
Yes. Yep.
It gets really annoying otherwise. Outside of the power by hitting the over button and then divided by. Question, what does this actually mean? Which might be a hard way of asking it. Correct answer is negative 1917.085. The way this is written, if I was to do 2 to the power of 4.7 and put over, what goes in the denominator? 7. Why does minus A not go in the denominator? It looks like it should.
But there are no parentheses.
Why? Oh, sorry, I didn't say anything. Yeah, go ahead, keep going.
Isn't it because like you're not supposed to have a negative in the denominator?
Technically, you're allowed to have a negative in a denominator. Square roots are where the negatives go messed up. Do you want to keep trying? Go ahead. Yeah, what was your next?
Order of operations.
Why does that make a difference here, though?
Because if it was the bottom, if it was 7 minus a, the answer would be different.
Yeah. If you were supposed to do subtraction first, 7 minus a, then divide, then we would group it and say 7 minus a, then divide. And we would go ahead and put that minus a down below. But PEMDAS says, as you move left to right, well, first of all, that's parentheses. You would do that initially. But then you would say you need to divide first. Divide by 7, then subtract a. So this shows divide by 7, then subtract a. Now, what if the problem was supposed to be 7 minus a in the denominator? What if it was supposed to be that? And this is what you put into your calculator. A, you would be wrong. B, how should you have put it in your calculator? Parentheses. Can I show you a quick trick? For something way better than parentheses. If you have Lo Siento, one of the newer calculators, not with the yellow second button. In your calculator, if I'm clearing all of this is not the problem. The problem came up with the answer that you just saw, negative 1917.085, the way it was written. However, if you were trying to solve this one, I want you guys to go ahead and, I am not doing what I want to be doing. Let's go down there and then let's go there. I want you to hit the second y equals. Nope. Lo siento. Alpha y equals. Oh, it's a hidden menu. That's fun. There's all sorts of cool stuff in this hidden menu. We're going to actually use this hidden menu for quite a few things, especially this Y bar over here. If you guys notice, don't these kind of look like the buttons, like the spacing of the buttons down below them? When you hit alpha Y equals, these buttons now, as long as this is showing, mean fraction, mean function. If you hit this button, it'll be matrices. If you hit that button, it'll be Y bars. Okay? So if you're in the second Y equals menu, these buttons now have new meanings, and they're going to go through, see what I'm doing? They go through the menu. Now, let's go just to this very first one. What do you guys think N over D stands for? Hit that one. Did you already try it? Ooh, look, I get to make it a pretty fraction. 2 to the power of 4.7 all over 7 minus a. And you don't have to worry about whether or not your parentheses are right, because you can see the fraction and you're doing it correctly if that was the question. Which it wasn't showing if it was. Anyway, cool. Alpha y equals hidden menu. For those of you guys that have the older calculator, once again, this whole ability to put values in different places and not just have the string is what your calculator is not able to do. So all of these things that like move exponents up or like put little change the index of a root or change the base of a log, all of those that are putting in, whenever you see me doing it, putting into a different place besides the normal string of values, that's what your operating system can't do. So keep with the parentheses. And then okay, let's go and keep going. Sorry, I want to show you that quick little trick. Because I'm going to use it throughout the year, and I don't want you guys to be like, wait, where is she? I've never seen that before. Oh, hey, they show the answer. Never mind. Have they been showing all the answers? Lame sauce. Why am I even checking them? Okay. The math menu was the next thing that you guys played around with. People with the older calculators, did we figure out how to use the xth root? Do you guys even have the xth root? Newer calculators obviously do, number 5, and all you have to do is just go ahead and go up, go left into that little power, and you can change that to be whatever you want. Like in this one, it was the 6th. Oh, this one they didn't give you the answer for. Okay. The 6th root of 64. Older calculators, what is that? Okay. For those of you guys guys with the older calculator just write the 6 before, I think. It should match up, right? The answer is 2. Where'd you guys find the abs? AKA absolute values. Where'd you find it? And then? Yeah, math over abs. That gets your absolute value bars. My older calculator people, it's just going to say abs with a parenthesis, and then you type in -5 plus 3 and the parenthesis. Once again, yours does not have the ability to put in these nifty symbols. What is the absolute value of -5 plus 3? Positive 2. Factorial, same menu. Go to the math. Number. Oh, I apologize, I went too far. Probability. Math prob. For probability. Combinations, permutations, some of those words might ring bells a little bit from last year. No probability last year? Okay. Number 4. Do you guys know that's called a factorial?
Yes.
Okay, good. So when you do 7, that's not really what it means, right? You can say it like that and just have fun with it, just not doing the test. But that's 7 factorial, and what does it actually mean? Yeah, everything starting from 1 going up to the number, but only working with integers, true? So, 1 times 2 times 3 times 4 times 5 times 6 times 7, you can think of it that way, or 7 times 6 times 5 times 4 times 3 times 2 times 1. What do you guys get for 7 factorial? 5,040, good. And then they had you playing with, oh man, look at all these different buttons you have to, well, it's not too many, all these different menus just to find the y-bars. So if you ever did want to do the y-bars, you would have to go, let's see, what does this say to do? So go to vars, and then go over to y-bars, and then hit the function. Wait a minute, did you guys just see these a second ago on my screen? What's another way of getting there? People with the yellow button, sorry, that's the way to go. But other people, where's that hidden menu again? Alpha. Now you could just jump if you remember which one it was. It was trace, you could jump there. Or you could do alpha y equals and then go hit the trace button because it's the y bar. Look, they're so close and convenient. If you need any other vars, if you guys want to see what else is hidden in there, if you didn't already go looking around. What if you didn't hit function? Huh. Those have T's in them all of a sudden. Interesting, there's a T. If you kept on going and tried maybe the next one with polar. Funny, those have R's in them. Well, you might not know where the theta comes from. Anyway, those different modes are for the different variable buttons. But we'll talk about them this year. Last but not least, this guy was a party, piecewise functions. How many of you guys got that graph? Ooh, I tricked most of you. Okay. How do you put, well, first of all, do you guys find a typo?
Yeah.
Not a comma, it's a decimal point. 0.5, not 0, 5. 0.5. However, they did tell you, if you guys looked up, you didn't just look at the number that you were supposed to do. If you looked up, they told you how to get to the inequalities. They told you how to get to the and. The only question that you might have been a little confused at is how do you get a forward slash on your calculator? We'll figure it out. How do you get a forward slash in your calculator? So easy, it's hard. Divide.
Oh.
Division does not always mean division. It can also have a programming meaning, kind of like the stow button. So, when you guys are supposed to put in your piecewise function, for those of you that got confused or got stuck, you're literally just trying to copy what they show down here in number 19 onto your screen. 20 was the harder one, because you had to come up with it yourself. But number 19, you're just trying to copy it in, so you're going to literally do the parenthesis and the 0.5. End parenthesis, you have your division. I know, some of you were looking for a forward slash, looking in like the alpha character or something like that. It's literally just a divide. But what it can also mean in programming is such that, in this context, Then we go ahead and we throw in the x. How do you find that greater than or equal to? Good, second math. And that's what the handbook up here was trying to tell you. And then greater than or equal to is number 4. And then you have 1. Do I now use alpha A, alpha N, alpha D for and? No. I go to second math. There is an actual command, and I need to use that command, otherwise the calculator won't understand. Go over to logic. There's that and. And then I have x is less than or equal to 5. What is this doing? What is a piecewise function? It's saying, hey, please graph this function, but only part of it. Which part of it? The part of it between x is greater than or equal to 1 and x is greater than or equal, less than or equal to 5. Where are x values? On the x-axis. X is 1 right there. 2, 3, 4, 5. 5 right there. The easy way of remembering x equals y equals which one's vertical, which one's horizontal is by the tick marks. X is 5 is right there, follow it. X is 1 right there, follow it. Between the line x equals 1 and x equals 5, only that piece of the linear function. Hence why they're called piecewise functions, like you're cutting them off. So you do the exact same thing for the next one. If you notice, they're putting parentheses around the function, using that division, parentheses around the inequalities. One quick note, how would you guys actually write this whole x greater than or equal to 1 and x less than or equal to 5? How would you normally write that, like mathematically, as an answer? Not with a comma. I mean, you could do an interval notation, that's true. But old-fashioned inequalities, wouldn't you sandwich it? Right? Now, sometimes you have to write them separately when, probably algebra 1, when you had, like, the graph going this way from 5 and this way from 1, there's no way to write them together because they're going 2 different directions. But when it's shared, you can write it as a sandwich. This might show up, oh, hey, isn't that how they wrote it? But is that how they put it in the calculator? You can't put it like this and have it understand the way it was programmed, the way your calculator was programmed. It's having me hit random things. Okay. The way your calculator is programmed is that it needs to see both inequalities going on. The x, you could do 1 less than or equal to x, just ignore that. You could do 1 less than or equal to x, and x less than or equal to 5. You just can't write it all together. Does that make sense, guys? So if you have something like 1 less than or equal to x less than or equal to 5, write each statement separately with an and in between using the menu. All right. So what was so hard with number 20? It was your turn. Take a graph and make equations. Someone who thinks they came up with at least a half right answer. You were able to come up with at least one of the lines. How did you do it?
I just kind of.
Yeah, but what did you have to look for? Does that make sense?
Look at the, I guess you said like where it starts.
Good.
So it's like it starts like 4.
Yeah, it's like 3 or 4-ish. What do you guys think? Because I just covered mine up. Does it seem like the top right-hand part of the graph starts at 3 or 4? What did you say? 4? Okay. So we'll say the intercept is at 4. Can you guys tell where it ended? Looks like 5, right? X is 5. And what's the Y? 8, maybe? Can you count the tick marks? 9, maybe? So it seems to go in between, for the first part anyway, it seems to go from the point 0, 3 or 4, something like that. And once again, you were just trying to read the graph and it wasn't super precise, so 3 or 4 would have taken either one. Approximately 5, 8. How do you make a line an equation of a line if you know 2 points? Slope. What is the slope if I rise from 4 to 8? If I rise 4 and if I run 5? So I could say y is equal to 4 over 5. Right? I go from 4 to 8 and I go from 0 to 5. Rise over run. X. What goes last in a slope-intercept form? Y equals mx plus b. And what did we approximate the y-intercept to be? 3 or 4, something like that, whatever you think it is. And who is this guy? One of the pieces, right? What would his inequality be? To see how there were 2 pieces in this one, they both had inequalities, what would his inequalities be? Less than or equal to, what's the farthest right it goes? 5, good. Seemingly, that's kind of what we guessed. And then how low does it go? What's that x value? Good. There's one piece. We could throw that in our graphing calculator, right? But what else do we have to figure out? Okay, so what do you guys see about the other? Now that we've all kind of gotten it, let's look for what? The intercept first? Or do you want to look for the left point first? I don't know. Let's do the left point first. What would you guys approximate? What's the x and the y at that left point?
4.
Yeah,
Negative 8, 4.
8, 4 sounds good to everybody?
Negative 8.
Oh. So, yeah. I wasn't thinking. Okay, how about the right point? Where does it hit the y-axis? Negative 4 again?
Yeah.
Wasn't sure if your picture was a little better than mine, so I was making sure. So 0, negative 4. So you guys, I'm pausing. I'm tapping out. Get me an equation with an inequality. I think I have the answer on the next page. So we'll check it. Using the same process I did from these 2 points, can you get the equation of the line for the other 2 points? What's your slope? Y equals? If you reduce, because you go down 4 and down another 4, so that'd be negative 8 all over 8. Negative 1. I'm double checking. Yeah. But I still need my, yeah, and what is my y-intercept? So you could do plus negative 4 or you could do minus 4. Okay, the same thing, right? Plus negative 4, you see the n. Well, some of you don't see the n, but it's that 1 in front, right? Negative 1. My intercept is negative 4, so I have my final answer of negative x equals 4. What was my inequality, or what is my inequality, I should say? I'm just following the pattern because they didn't really show holes, like whether they were filled or hollow. For you remember how sometimes they're open circles, sometimes they're closed circles. They didn't show me that, so I'm just kind of copying. Good, because the farthest left it goes is negative 8. Once the farthest right it goes. Now the reason I'm not doing or equal to at the 0 for sure is because the 0 already got included, so I can't include it twice. If I did, it'd fail as a function because of the vertical line test, but that's all review stuff that now is not necessarily the best time to talk about. How would that look as a piecewise function? Oh, I said it was 3. Close answer. That's okay. I just guessed it was 3. We were pretty stinking close. This is how you would write it as a piecewise function. And remember I said there could be a little variation in that it was hard to see if this one was at 3 or at 4. So if it was at 3, the slope would have changed a little bit. But for our purposes, for what we did in class, we said it was at 4, which changed the slope just a little bit. So we'll go ahead and make this piece 4/5 x plus 4. Because we knew it was one of them. We just picked one. But this is how you would write a piecewise function. You would name it f or g or h or whatever you want to name it of x equals, put a brace. You can technically put them in either order. Does anybody know why I put this one first? I like them more.
Is the 2 equal?
No, not really the 2 equal ones. I was just thinking like moving left to right in my graph. Because usually when you read, you go from left to right. You're going to see this year even more. As we read a graph, we're going to go from left to right also. So I was like, hey, this one comes first. This one comes second. So that's technically the proper way of writing it. And as you guys see, we chose, or I chose, in an earlier time. This wasn't from this year. And I think it used to be number 18. But I chose to put the inequalities in different places. Long story short, we just can't have the or equal to, once again, be in 2 different places for one number. That's not good. So we go back to our work because this is kind of an old version of an answer, but I wanted to make sure that you guys saw how to write it properly. I don't really even like the way the handbook wrote it because they didn't write it very nicely. Technically, the way they should have written it, they were writing it like a calculator would, in a sense. The proper way of writing this for when you see it later would have been something like g of x equals, and you might want to write it down in your handbook just so you see the proper way of writing a piecewise function. It would have been 0.5x. You write one function name, because it is one function. It's 2 pieces that make one whole. You would write a name, you would have a little brace, and you would put one equation on top and you'd put the other equation on bottom. I don't even like the order they put it in. But that's okay, I already wrote it, so I'll just leave it. It technically would work in your calculator. It technically would work as an answer, it's just not super proper. Pretend you can see that. But do you guys see the proper way of writing it piecewise? Okay. Take the 2 pieces. Sometimes there are 3 or 4 pieces. Put them into one brace with one function. Go ahead, Chris.
On the -8, down there near the bottom, we would put the equal to sign
You could
below.
put the equal to sign. I just didn't know if it was a whole, like if they intended it to be filled or not. So the same way that, I guess they could have just made all of them not equal to. But it would be valid if you wanted to put it. I would say that's okay, just don't put it there. But you could also make the argument and be like, well, I didn't know for sure whether it should have been filled or not. I would have been like, okay, that's true. That's fair. And if it is on the quiz, and if there is something similar on the quiz, if I had one definitive answer, I would have had to have shown the filled circle or the hollow circle. Alright, this completes our new filter. You did have calculator worksheet number 2. That's technically homework tonight. I don't know if we did the best for this one. It's that parent teacher fellowship meeting. It's fun. It's not bad. What we're supposed to do now. Unless we have to look at it. We do need to look at that calculator worksheet number 2. As you guys are opening it, I want you to read problem 1. I did not say do problem 1. I said read problem 1. Kiddos, when are all the forms that need signatures due by? Which is? Yeah, tomorrow. I need to change the backboard just so you guys realize. Friday isn't as far away as it used to be. Which is a good thing, right? But we also need, what else? We need the papers with our signatures, or with yours and parents' signatures, turned in to me. You need 3 forms turned in online. Textbook. Textbook. Let's get the year going, and
The parents.
parents. Parent guardian. 3 forms turned in. Technically, I guess that could be by midnight, and it would still be tomorrow. But it needs to be turned in. Don't procrastinate. Supplies. We're not really using our composition book, but you should have one. You are using your pencils and your colored pens. You are using your graphing calculators. What supply could you forget and it would be really obvious tomorrow? I see yellow books, and I shouldn't, because they should be by tomorrow. covered. So bring your book tomorrow. That way I can check it and make sure that everything is good. Bring your book tomorrow with it covered.
Where do you find the forms on the website?
Yeah, do you know how to get to my website?
Yeah.
Okay, go under Precalc tab, because there's the tabs at the top. And then under announcements, the welcome, I think. Don't it say welcome? Like welcome to the account? Scroll down, both of the student forms are there. Let's get the year going and the textbook form. Parents have their own little tab. So not the Precalc tab, but the parent tab. It's all. Is that cool? Okay, calculator worksheet number 2. Did you guys read number 1? Can you guys tell just by looking real fast, like this? What part of the calculator handbook is this worksheet on? All the lists and the stat plots and the regressions. So if you want to make yourself a little note at the top, this would be handbook pages, I think, 7 through 10. If you need help on the wording, what to do in your calculator, this can be found in the handbook, pages 7 through 10, okay? However, I need to show you a couple things. First of all, number 1 does say find a linear regression, but can you do a linear regression if you haven't made your lists yet? No. So first of all, you're going to need to make list 1 and list 2 from the table that they've given you. But question, which one is list 1, which one is list 2? They didn't tell you. They just said year and population. What do you guys think? Year is going to be like the X value. Population is going to be like the Y value, which means I'm going to make the top one list 1, the bottom one list 2. What do you guys think for number 3? Time comes first, then height. Which one do you think is X and Y? Which one do you think is L1, L2? Time is X or L1. Height is Y or L2. We'll talk more about Y as we get into like the book and actually get into reviewing functions, independent, dependent variables, yada yada. Okay, I need you to see one more thing from number 1. Do you guys see how we're doing 1,980, 1,985, 1,990? Is that really what's going on here? What do these top quantities represent? The year. We don't really say year is 1,980, right? What do we say? 1980. What do the directions say up above for what to let 1980 equal? So I'm letting 1,980 be 0? That makes no sense. No. I'm letting the year 1980 be 0. So that the year 1981 can be, if this is year 0, then what's this year? 1. Okay, so hold on. Who's this going to be when I put him in the list? 1980? No. I'm going to make him instead year 0. This one's going to be year. Oh, I get it. 10, 15, 20. Let's keep going.
No.
Not 20. How many years from 1980?
18.
18. Why would they have us do this? It makes no sense. If you were to graph this little bit of data between the years 1980 and 2002, where would it show up in your 10 by 10 grid? If you put 1,980 as the first one?
No.
Look over there. Right there. So if you zoom out, zoom out, zoom out, zoom out, you're over here in like 10 by 10. You're trying to get to some, like, wait, how do we jump to data? What zoom do we use when we're using stat plots? Okay, so zoom stat could get us there, but then where's our X and Y axis? Way back there. We're just making it all easy and saying, no, 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 no. 1980 is year 0, year 5, year 2. Imaginary bell ring, sorry. Wait, you guys get out here. Do that worksheet tonight. Come tomorrow with questions. Tomorrow is our, make sure that we don't have any questions on calculator worksheet number 2 or any remaining questions on the handbook because we're studying for our quiz on Monday. Bye guys. That's why I was like, it has to be right now because it's a little travel. It's not just such a
Right. Just select that